Hi, I'm going to talk about positions that are used to assign textures on surfaces. So we are very used, for example, to use UV maps to basically, we know that, let's say if I do a UV map that it's inside the UV space, that whatever image I put in there, it's going to use those positions to assign a texture on the same locations and the same corresponding locations on my mesh. Now, most of the other projection methods, the other mapping methods, they don't use a separate set of positions to do that. They just use the positions that the mesh has itself. And so it either uses the object spot, which is the positions that the mesh has when we open up in Modeler, or it uses the world spot, which is the positions that the mesh has after we transformed it and we did all sorts of things to it in layout. And so that can be, you can choose between one or the other when you toggle world coordinates. So when you toggle world coordinates on, you're using the world spot. When you toggle it off, you're using the object spot. Now, let's look into how things are transformed, how those positions are transformed by these input scale, position, and rotation. So I'm going to turn on VPR. And you'll notice that I have here this texture, and it's using the planar projection, and it's set to be on the z-axis. I also have it set to reset on the tiling so that I can just see one and not many repetitions. So it's easier to explain things in this manner. So I have it to reset, and so I have here this item info with the item transform. This one here, this yellow one, and you'll notice that as I transform the item, you can see the map, the texture is changing as well. And well, what's going on in here is that I'm not actually transforming the texture itself. What I'm transforming are the positions that are used for the mapping. And so actually, instead of doing, let's say, a straightforward transformation, I'm doing an inverse transformation. And we can check that out by let me look into how to replace those texture spots, those positions that are used to assign the map. And so there's three ways to do that. We can use the replace spot by Denis Pontonier, which is, I think it's the easiest one. And so in this case, I have here this, Denis has a lot of mapping nodes. So if I come here, dpkit mapping, it has all these sorts of mapping projections. And so here I have the planar projection. And so we know that you can see in here that this texture is not going from 0 to 1 like in the UVs. So the UVs, we know they go from 0, 0 to 1, 1 on X and Y channel. And so we get something like this. But you'll notice that here it goes from minus 0.5 to 0.5. And so it's going to look like this. So if I put here the, let's say the object spot, and I just focus here on this square where my, let's say that mixture, maybe to make this a little bit easier to look at, I'll say that I'm going to put this here, I'm going to put alpha in here, and that didn't work because the alpha should go into opacity. Okay, so this is gonna look like this. So the spots being used on this planar projection look like this, while for example in this case of Denis node, they're gonna look a bit more like this. And so they go from 0 to 1. And so since we have many things, some things that are from 0 to 1 and other things that are from minus 0.5 to 0.5, there's sometimes the need to do basically some conversion between the two. So to go from here to here, I just subtract 0.5. I go here to here, I just add 0.5. And so in this case, since the replace spot, it uses something like the planar projection. It expects positions that go like this between minus 0.5 and 0.5. What I have to do, since then is planar node, it's giving me values between 0 and 1, I have to subtract 0.5 to it. And so by doing that, now if I put this in here, you notice that it's going to look like the object spot. Okay, so by doing that, if I just put this in here, and if I put, in this case, this is being transformed, it's going to transform invert node. But if I do nothing to this control item, it's all good. And so if I put that in there, I'm replacing the texture spot with this planar node. Now, you'll notice that the transform node that is in here is not transform 3D, but it's transform 3D invert, because the transformations that are going in here are inverse transformations on the texturing spots. And so you can see that this is basically me proving that. And you can see that if I transform these positions that come out of the planar node, you can see that it behaves the same as with the image map. So this is going to behave the same as this one here. So the transformation that goes into these inputs is the inverse transformation of the spots, the texturing spot. So this is the one way to replace the spots. The other way is to use the color layer plus, and so inside, let me put this to reset, and if I plug the spots, the texturing spot in, for example, here in object position, if I put this in here, you can see that I get basically the same thing. And then the last one, it's basically using just an image node. It's just, you know, there's more things to be done, and that's why I think the replace spot is a very handy one. But you can do this with a native node. Basically here I have the spot info node with the object spot being taken out. So basically I'm doing a delta in which I take out the initial positions, and then I just add the positions that I want. So in this case, I'm adding these positions that come from the planar map node. Now, while those positions could be enough to perform the transformation, since what goes into these here, it's the inverse transformation, well, I'm going to have to put a sign node in there so that it basically changes the transformation. So we know that if I have let's say a minus b, if I feed here, if I feed 3, I'm going to have minus 3. So if I want to add 3 instead of subtracting 3, I have to negate my input, and so that's basically what's going to happen here. Because then this way, if I replace b with minus 3, I'm going to have plus 3, right? And so that's why I'm doing putting this sign node in here. And so by doing that, you can see that I get the same behavior. So basically, I effectively replaced the texturing positions with another set of positions. Now let's look into some of those mapping projections as just to look into them, and why the reason for all this work. Why does it matter that I replace the positions? What's the issue? And so I'm going to go into this to this sphere. And so this sphere has some of those mapping nodes going on in there. So here it's just basically the same planar z-axis projection. And here I'm going to replace the spot with some of these. And so, for example, here, let's say here I have again the planar projection, just the same way as this node. I have, in this case, these 3 projections that use an axis, planar, spherical, and cylindrical. They need a subtraction by 0.5. Otherwise, as you can see, they go from 0 to 1. And so here I have the spherical, and you'll notice that that goes here from 0 to 1. And so I have to subtract the 0.5. But so I can in this case I have the planar just like the native node. Here let's say I can do a spherical projection, and in this case I'm doing that on the z-axis, and so it looks like this. And I can do the same here with the replace spot, and so I can put this here and put this here. You notice that it looks the same, and I can do the cylindrical, etc. So all of those projections that I have in here, I have also in these nodes by Dennis. The reason for that, for all this, is that some of these projections don't work with the transform inputs. So for example, if I put here this, let's say front, and the front mapping works for the camera. So in here you can see the camera. Let me go into the camera view in here. And so in this case, this is mapped for the camera. You'll notice that the image, it's a bit stretched because the camera is not, it's not a perfect square. If I make it a perfect square, something like 480 by 480, you notice that now the image keeps the original proportions. But you'll notice that I cannot change. If I change the position in here, let's say 0.5, this doesn't respond. These inputs stop answering to whatever I put in here. The same will happen with UV mapping. And so let me put this into UV. And let me put this, the texture. And so this is UV map. Let me come out of the camera view. And so this is applying the texture using a UV map. But the scale, position, and rotation, you see that they are grayed out. So I cannot, have any displacement, any distortion of my image using these inputs. Because usually, if I put this into planar, usually you can just grab, let's say, a procedural, and you can, let's say, put bump into position, and you have some distortion. You can have some fun distorting your textures. By doing so, you can have some sort of, some sort of instructions for the rotation or for the position or for the scaling. But here I cannot have that for UV and for front projection. So that's a bit annoying, and that's why I'm going through this, because these nodes allow me to have access to those positions, to transform them and replace the texturing spots and have all those custom changes done to them. So for example, in here, instead of, let me put here the UV, So while I can't do this into the position input when I have a set to UV, I can do that with the UV mapping positions. And so I can just add that in there, and I can have the same sort of distortion done to my UV positions, right? So same for the front. Here I have the front. Let me go to the camera view. And so I can, for example, add this procedural. And so I can now distort my front projection, something that I could not do with the image node. Right, so let's look into an example where I already used this, but I'm going to go a little bit further with it. You can see that here in this case, I also have this UV node set to texture, and if I put that in there, it's gonna look a little bit different than this one, because this one goes from 0 to 1, right? The values here go from 0 to 1, and the values that are expected in the replace spot go from -0.5 to 0.5. So in this case, this one would require this operation in here. So if I put this, now it looks the same. So you don't need to use Denny's UV node. You can use the native one. It's just that you'll have to subtract 0.5 to it. So it's up to you. Now, the thing that I already talked about, and I'm going to look at again, is to have basically one UV texture and basically just, choose like I could have multiple images in a single image, and I could just map a portion of that image to the whole UV space. And so that's what I'm going to look at. So here I have these characters, these symbols, and let's say that I have this mesh, and as you can see, the UV space goes from each side, goes from 0 to 1 and 0 to 1. And let's say that instead of having all of them, I just want A or B or a number or a symbol mapped across the whole UV. So to do that, I'm going to basically transform the UV position. And to the logic behind that is, let's say that I want to go to this position here. What I'm going to do, and let's say that this position here, I'm going to basically transform an index into a grid location. So in this case, T has the index 19. And so on this grid, which is a grid with a size of 5 by 10, T has the coordinates 4 and 3. So 0, 1, 2, 3, 4, 0, 1, 2, 3. And there's my T character, right? And so this transformation of an index into 2D coordinates, I already looked into them in the integers video, but you can look into them again. So here I have the integer division and I have modulo. And so the integer division is gonna, basically the mindset behind this is that as I start to go up with my integer, I'm going to jump across the grid. And so let's say that I want to look for the integer 6. And so I start here at the bottom and I go 0, 1, 0, 1, 2, 3, 4. And then there's nothing else to the right of it. So what I'm gonna do, and I'm gonna go back to 0, but I'm going to go one up on this other coordinate. And then I go, and then instead of doing 5 to the side, I do 5, 6. And so in this case, G will have the index 6. And so this sort of, this sort of logic, it's the one that's going to allow me to iterate all over from all these rows and get to whatever I want into this image. Right, so after that, and so basically here in this case, the example that I'm giving is using T, which has the index 19 and the coordinates 4 and 3. I have my UV map filling the whole UV space, but so I'm going to move it according to the coordinates on the grid. And so I'm going to move it 4 to the right. So here I move this 4 to the right, and I'm going to move it 3 units up. So here I move 3 up. And so this is going to be the location for T. Now you'll notice that, of course, this is the image, the UV texture is going to repeat. And so what I have to do to put this back into the 0 to 1 space is I have to divide by the size of my grid. And so this 2D array is 5 by 10. And so by dividing these positions here by the size of the array, I get those positions here to actually come back into the UV space, the unit UV space, but on that desired location. So that's why I have here this division here, as you can see. So I have the UV size 5 and 10. So I have this vector here 5, 10. And after adding the values that I wanted, in this case it was 4 and 3, I divide the result of that by 5 and 10. Now, these will result in positions that are thought out for values that go between 0 and 1. if I want to go from 0 and 1 to minus 0.5 to 0.5, I have to subtract 0.5. And that's why I have here this subtract node where I subtract 0.5. And so this allows me to use these positions in the replace spot on the object spot. So let me do that. Basically here, I'm going to have some instances that I can use their index. And so I'm going to come here to scene editor instancer, and I'm going to activate those instances. And I have an array of 5 by 5. And so I'm going to have 25 instances. And as I plug this in here, you'll notice that now instead of having all the symbols, I just have one, and it's basically going through them using the ID, the index of the instance. And so I have in the instances, actually it's not going left to right and then bottom up. It's actually going to go bottom up first. And so you have 0, 1, 2, 3, 4, 5, 6, right? And so it's going up first and then it's going to the side. So it's a bit different than what I drew in here, but it's basically the same rationale. So I have these, and so this allows me to have basically access just portions of the image. And so I can, for example, also use this rotate input. Let's say if I want to rotate this 90 degrees, I can do so. Or let's say that I want to have some random assignment of 90 degrees. Maybe I want to have some instances, the texture to be rotated 90 degrees, others not so much. So I can do that, for example, with the instance info fixed random. And I can, let's say, multiply this by, let's say, 4. So it goes from a range from 0 to 3 if I floor it. So then this will give me random values between 0 and 3. And then I can multiply that, scalar multiply, I can multiply that by 90 degrees or pi over 2. So in this case, I'm just going to use the pi constant, the pi node, pi over 2, it's 90 degrees. And if I put this in here, you notice that now the instances have a random rotation of 90 degrees. Some are rotated 90 degrees, others are rotated 180 degrees, and others are rotated 207 degrees. So this is the way this compound I've done has this input, so we can do this sort of thing. Now, this is using a UV map. And it's thought out for the native UV node, but I can use the Denny's node. I could split the values in here, but in this case, I decided to also do a compound that does this sort of grid for 3D. And so let me change here the instances. Yeah, for now, I'm gonna leave it as it is. So instead of using this one, I'm gonna use this one. And you see that that's basically the same. The difference is that instead of using that assignment of positions on a grid just for 2D, it's going to go an extra dimension, and it's going to do it for 3D. So in this case, it's working because I've set the size of the grid to be 5 by 10 by 1, just like this one here is 5 by 10, but there's no Z coordinate. But in this case, it's set to 1. But I can, instead of using this, I could just let me take this out. So I don't care much about actually, I don't think I care much about the UV in this one. Oh, no, I care. So I'm just going to put that in there, and I'm just going to put the normalized in here. And so you can see, yeah. So I actually don't care about the UV in this one to show what I want to talk about. So you can see that this goes from 0 to 1 on the Y channel and goes from 0 to 1 on the X channel. Now, what if I add more instances, right? What if let's say I put 5 on the Z-axis. Now I get this. So let me change the size of this to, instead of 510 1 to 555. Right, now I have some transitions that goes from 0 to 1 on the Y channel, 0 to 1 on the Z channel, and 0 to 1 on the X channel. And so this way what I'm able to do in here is to basically create this grid out of these positions. Of course, if I increase the number of instances, this is going to cycle. And so let's say that I put 10 in here, right? If I put 20, and it's going to cycle through those. It's not doing the same way that I've drawn in there, because the instances, apparently they do the Z axis first, and so it's going to be a little bit different. But it's going to go through those IDs. So 5, it's back to 1. Okay. And so the other thing, well, actually I can put the 5 there again. And another thing that the replace spot allows me to do is, for example, I can use the instances position to be the spotting texture. So let's say that I'm going to have here another ripples ripples texture, and I'm going to replace the spot of it. And to do that, so you can see that at the moment they are all being textured the same. Of course, I can put world coordinates, and now they are textured, according to their world position, the world position of the spots. But let's say that I want them to have the same value for the whole instance, not just not have all these transitions going on, but I want to look at this as some blocks. And so what I can do that is I can replace the texturing spot instead of using the let me put here spot info. So you can do the same toggle that I've done in here. You can sort of do that with a spot info node. So in this case, it's using the world spot. So if I want to replace that, I have to plug something into the world spot input. And if I put the world spot into the world spot, you're going to get the same thing. But if I put the object spot in there, you're going to get the positions that we have in Modeler. So you can do this override irrespective of the texture. Basically, you're replacing the texturing spots in here. So this, in the end, doesn't matter what's in here, because you basically, well, it doesn't matter. It matters what's in here, but it doesn't matter. What I mean is it doesn't matter the initial spots. If you're replacing them, it could be world or object, you just choose. But now let's say that I want each instance to have a solid color, a single value. So I can replace the texturing spot with the instance's position. And so if I come here and I put the position of the instances into the world spot, now I have a single, all the instances spots are to be considered to be in a single position. And so now if I scrub the timeline, since the ripples procedural is animated by default, you can see those changing. And there are some people that use these to assign colors. I for one use the random colors compound, but you could always put 3 of these, and let's say I'm going to change the scale to 2, 2, 2, and the scale of this one to 4, 4, 4, and I'm going to put here a make color, and I'm going to put this in here, this in here, this in here. And if I put this in here, now you notice that you'll have several colors going on. Right, so there's many things that can be done by replacing the texturing spots. It definitely allows you to have what you want to be used in the texture assignment. One last thing that I want to look into is the ability of having 4 positions to define that mapping space. So I have here in this plane, we come here, I have these 4 yellow positions, and they are being used here in this compound called corner pin 4 to define the corners of the image. And so if I plug this in here and I move those positions, you can see that I get the image to be constrained within those 4 positions. It's not a perfect implementation, but it does allow some room to play with this sort of effect here directly in Lightwave without having to go to another application. And so basically I have the spot position of the mesh being transformed by the four positions of those 4 nulls. And you can check inside. It's basically a bunch of projections. Like I said, it's not a perfect implementation, but does allow to some room to play. So that's it. Hope this is useful to you when you want to texture things and manipulate how an image can be mapped on a surface. Cheers.